Hello, this is Max, and I'm going to be doing the training today, or the webinar on Wire EDM. And so we have a part here, and we'll maybe just wait a minute for maybe a couple more people to join in. All right, we're getting a couple people in here. We'll go ahead and get started. So covering Wire EDM today is just going to be kind of going through some of geometry setup, how the toolpath will end up getting set up, and some of the new functionality that's inside version 38. And so we'll get started here. Kind of already did a quick demo piece earlier today, and we can basically just get rid of this geometry, and we'll get rid of this job as well. We can pretty much just start a new file here. Starting with 2-axis wire, things can be pretty straightforward. So if we just set up our geometry right on Z0 here, we can customize this a little bit. I'll say something like that. ahead and hit OK. For 2-axis wire jobs, even if you're cutting a tapered job, this is sufficient geometry to go get that set up. And so you don't really need a full solid model or anything necessarily like that for setting up a wire EDM job. Sometimes it's helpful to have that, so you could pull chain geometry from, say, the top and bottom edges. So if we're looking at the stock here, kind of represents our block there. Same thickness and everything. But when you're setting up these parts, 2-axis is just 2-axis geometry. It's going to be a single chain on one flat plane, whereas on 4-axis you have upper and lower geometry. And so sometimes having a solid so that you could use something like extract edges and go pull geometry from an existing solid can be helpful. But in this case, if we're just starting with a 2-axis example, this is really all we need. So we can get started with setting up our wire job. Go to new job, select wire EDM. Let's go select our Mitsubishi FA series just for fun here. We'll go to our stock wizard. We don't have a workpiece to select. This is something that in tech support calls, people ask me quite a bit about. You'll notice right now I can't really go and select anything, and that's just because this workpiece selection is looking specifically for a solid model. This is useful when you're setting up simulation. You can kind of see the deviation between what the solid model looks like and what the actual toolpath is going to do to that part. And so right now we don't have a workpiece to select, so we'll skip past that. And we'll set up our stock. Let's go a little bit over. We'll do some different things in here. We'll make it an inch thick. That'll work for me just for this example part. We'll get to this more exciting, fun example of a solid model here. Obviously, you can see this is a little bit more feature rich, but just getting started with 2-axis, like I said, you really don't need anything too crazy. You can just stick with this, 2-axis wireframe geometry or 2D wireframe geometry. So we'll go ahead and hit next. And here is our machine setup. GN wire we're going to be setting up on the bottom. G54, we're not going to do any work offset XYZ, and we'll hit OK. So this is our setup. We'll start here by going to a 2-axis inside. And we have our feature geometry picking here. Now this is where if you're kind of used to the software, what I'd call like a seasoned user, an old school user, before our picking manager existed, we would hold shift and click on an entity and it would pick everything, versus right now if I just go ahead and click on that while not holding shift, we're just getting single entity selection. And so this is something that can be confusing if you don't know what you're looking at here. So we also have this picking manager right here, and this will allow you to either auto connect chained geometry, which usually just means it's touching in some way. So if I click that, it goes ahead and picks the whole thing, and I didn't just hold shift to do that. And so most of the time I run this without that on, just because I've used the software long enough to get used to shift clicking. And so your picking manager should always kind of remember the state that you last used it as well. So in earlier versions, 37, this would kind of reset itself. Nowadays, it should work very similar to how you're seeing it right now, where I leave it off, I could exit this function, come back into it, and it will remember the state there. And so if I hold shift and click, we'll do that. There we go. That's our chain. We don't have any stop points that need to be selected on this part, so I'll hit OK. And as you can see in here, if you haven't been using version 38, this is one of the reasons to start, is without hitting compute, without going and setting really any parameters in there, you could already see that the toolpath is generated. We get a good look around there. That's all done already, just by selecting the geometry inside version 38. And 37, we have the old CAM wizard. This is kind of the new style where we're using the data entry tab and we'll continue through. So we'll turn off glue stop, and continue working through here. You can see it's already thinking about the changes that I'm going to be making here. And this is kind of an important spot to touch on real quick while we're in the 2-axis wizard here. Is a lot of people think if you're doing any kind of tapered part, you always need to have a 4-axis, and you need the top and bottom geometry, and you need the sync lines and everything set up. You can set up taper operations and land and taper, and it's going to be based on degree values here, right? So if we look from the top down and we maybe change some of these values, we continue on here. As we get into further into this part, the toolpath preview is going to show us those things happening. And so we'll just leave it a rough and a skim. That's cool with me. Not really going to be making too many changes in a lot of this stuff. If you're ever looking for your wire diameter or your wire settings, those are going to be in your current settings. We'll kind of go back to that because there isn't really a way to change that in this wire window right here. We'll continue on through posting. Not going to be changing anything here for how the post output is going to be looking. We're not changing our work offset or anything like that. Our machine sequence, we'll just leave it to closest as it's a single chain. We're not really doing like a sequence of shapes or anything like that. And we'll go on to our parameters here. And you can already see the difference in the geometry. If I get a top-down view, you can already see this is kind of what I was talking about with that taper, right? You can see that the geometry that I selected is right here, and we have the taper being applied from the bottom, which is exactly how we told it to do it. It's also taper from the top if you don't do that, if you leave that unchecked. And you could also do a land and taper operation where you'd specify the land height, and you specify whether the land's on top, and the same thing, that taper angle. And so if you're doing something with a land followed by a taper, you could still do that with 2-axis wire EDM and still just with 2D wireframe here. So a lot of this stuff gets a little bit simpler once you kind of understand what you're looking at, what options do, what things to your toolpath. For this setup, we're going to just go back to none. I just kind of wanted to show that taper angle in there once we kind of got started on setting up the toolpath. So we're not going to do coreless, but we could do coreless. We could compute coreless, and we'll give this a sec here. 50% step over, that should take just a moment. And so we have a few people in here. Are you guys wire users? And if so, are you guys using the version 38? Seeing if we could get anyone chatting with us here. Bear with me 1 second. Just running into a little technical difficulty with my screen sharing now, so just bear with me a moment. about that. Should be figured out here. There we go. Now we should be back. I don't know what just happened with the stream there. It looked like my setup just turned off there. So we'll get back to this. We'll go back to our job. All right. So right back into that toolpath. Apologize about that. I canceled out of that operation. Go back to inside. Pick our geometry. We'll double check our chain. We'll get right back to where we were. Let's remove our glue stop. Get right back to where we were at. So this is where we were kind of at. So system compensation by default is going to be off. A lot of the wire users that I talk to say they really don't even use the system compensation. It's more just the machine compensation. So the changes that they make can be made right out at the machine. Apply stop points. If this is checked, it's going to apply those. Obviously, we don't have any stop points selected right now. And so we'll go continue on. For corners, external and internal corners, these are options to change how corners are processed on your part. So you can kind of see it's highlighting some geometry where it's seeing those changes could be made. And you'll even see the little changes being made if you're using certain options in there. We're going to leave everything on sharp. A wire with a diameter of 80 thou is a pretty precise tool, so we'll just leave it sharp and not have to worry about it changing anything with the geometry. Usually I just draw what I want to cut. So we'll go ahead and hit next. This is for our lead-in, so if your machine allows, auto feed threading and stuff like that, thread vertical. We could set up a hole right here as well for the diameter of the hole that it's going to be threading through. And then you have a whole bunch of lead-in options. This is mainly what people are coming to the leads page for, is how can I have this lead into my part? So we have a whole bunch of different options. By default, it's going to be set to perpendicular like we see here. We can go to circular, which on certain inside cuts like this might not be the best option. We'll be getting outside the part a little bit there. But you can change the values to really whatever you want. We'll set 40 thou instead of 25 thou. There we go. Excuse me. You can change the length. Maybe we'll make that 40 thou. And you can see how that change happens right away without having to go compute the toolpath like we used to have to do in the previous versions. We got that perpendicular blend where it's going to kind of try to do some kind of arc radius in addition to the perpendicular lead in, lead out type. So we'll see perpendicular here. We have parallel where it's just going to continue. This one is extending from the front, the start of the chain, and exiting out just parallel with the lines that it's cutting. So in this case, perpendicular is probably what we're going to want to leave it on. We also have a select point and point blend. Select point would allow us to pick a point, say we're somewhere over inside of where this part is going to be getting cut. And say we got a point right here. It will lead in and lead out from that position and move back and forth to that position and point blend. And you can kind of see this just with the center point here. Select point, go directly from that position to a different position. So we have our first point X, first point Y. If we change these values, it's going to shift that point around. And you can see what I mean with the blend, where it's always going to try to do some kind of arc included in that. And so we'll leave it on perpendicular. We'll be starting from that corner, finishing on that corner, and that should really be all we need to look at there. Getting into our cutting conditions, some machines will have a cutting conditions database assigned to them. If we finish this for just a moment, I'll kind of show you where you'll see those things. So we have our Mark 21 picked here. And you can see this is linking to the Mark 21 EDM cutting conditions database. Now, from a whole lot of feedback from customers that I work with doing technical support, a good majority of the machines nowadays are allowing you to set the cutting conditions, for whatever material you're cutting and things like that, right at the machine. You load that up right when you're loading up your G-code program. And so in some cases, you will see that this is not using a cutting conditions database. A lot of times that's just due to the setup that you're using here. And that's really it. So just wanted to mention that if you don't have that as an option in there, more than likely that's why it's just not tied to some database in the background. If you guys have questions about that, you could always talk to us and support or posting those. We'd be able to answer questions as whether that's even something that's necessary for your machine. So we'll continue on here. We'll get to a skim cut. And a lot of this is going to be, just the same stuff. Skim passes have a couple different options here. So you could flip the pass direction. You can skim in the same direction, reverse skims, how many skims you're going to want to do. And then the same things really that you're seeing in the parameters up here. How are we compensating for the wire? And are we applying the stop points? Maybe we'll do reverse skims just for fun. Maybe we'll put 2 of those in there just to keep it exciting here. And we'll move on. And like I said, a lot of this stuff is very similar content from the rough to the finishes. Like I said, this is kind of the main stuff here is contextual changes for skim passes. How do you want those skim passes to go? And so we'll go to our corner types. Once again, we're not going to be changing anything here. We'll go to our leads. Maybe for this one, maybe that slug has been pulled out and you just want to go skim past this. We'll do select point and you can kind of see how that'll feed in simulation. We'll leave that same for the lead out. And the cutting conditions in this case are just going to be whatever is linked to that database for this Mark 21. We'll go ahead and compute. And you can see that, that toolpath, the exact same thing that we were looking at before. Nothing really changed from what you're seeing inside the CAM Wizard nowadays to what you're seeing, once the toolpath's been computed. And so here's our toolpath. You can also see it's kind of showing you where everything's kind of being seen as a corner, kind of with these vertical lines here. 2-axis wire doesn't really need sync lines. That's why you don't really see the choice for it over here. 4-axis does have the option for sync lines, and we'll get into that in a little bit. But version 38 is getting pretty advanced with how it's recognizing the parts and where it's supposed to sync up. And a lot of times it's based a little bit more on the chains that you pick, kind of similar to the chain that we have right here for the top and bottom geometry. For this one, like I said, this is kind of a simple part, just as a run through of a wire EDM 2-axis job. And we'll go simulate this. There we go. And so we'll go ahead and run. Give us a little more room here. There we go. And so it's basically just tracing what we just saw there. Right now, you don't see a ton of good information on this. You're just kind of looking at the top and the bottom. And so little tip for simulation here. A lot of people, when I'm doing tickets and things like that, trying to verify toolpath is looking good, if we're cutting out many pieces or whatever the case is. We have a couple of things in here that are well worth knowing about. So the first thing is inside of our measure tab here in simulation. If you're cutting out many parts and you kind of want to see the finish on, one example or something along those lines, you can do that right now. Like I said, you can't really even tell that a cut's been made aside from the black line. We can't go look in there too well and see how this thing cut. And so in the measure tab, you have all these different measurement options, and you'll see some of them are remove chips. And so if I select remove chips, select chips, I could go click through and select, the things I want to have basically disappear or be hidden. Remove chips, only keep one part is the main one that I use if I'm looking at, kind of a specific example. That's the one we're going to be using right now. And you can see the other ones there, auto-defined targets with tests based on volume. Only keep one part really allows me to select the main thing that I want to see. So in here, like I said, we kind of just have our cube, but if I click and I have just a regular mouse, left button, right button, and then I have the scroll wheel. And if you click your scroll wheel on the part that you want to keep, just like that, you can see that's what our cut is going to end up looking like on the inside. Now, this gets a little bit more fun with, the 4-axis parts where you can see the actual, spiral cuts and tapered cuts that you can end up making with that. If we exit our simulation here, just go to File, Exit, or just click that little X up there. Get back to the interface. Let's throw a taper on this just for fun. This is something that people ask me about in tech support sometimes, and you can end up getting some more advanced parts from, just like I said, simple 2-axis geometry. So we'll set maybe a 5-degree taper angle. Our land will be on the top, and we'll set it down a 1/4 inch. This is a 1-inch thick part here, and so we'll continue through. And you can kind of already see we're doing the initial cut, and then we have the taper cut following that. So we'll apply the taper there. Let's continue through and pretty much just compute this. And you can kind of see it breaks it up into 2 separate toolpath operations. Let's go simulate that. There we go. We can slow this down a little bit. You can kind of see what it's doing here. And actually, we can go ahead and make our stock transparent. We could really see what's happening in here. There we go. So we're doing our taper cut. And then we have our land cut happening following that. So if we turn our stock back to show, and then we keep our one part, you'll see we have our part applied with our land at the top. You can kind of see it. The graphics there are maybe a little bit difficult to see in the recording there, but a clear line right here where our land should have ended. And if we look from this side, here we'll go look at the bottom view here. You can clearly see the taper applied there as well. And so that might not be the craziest taper angle or the most complex geometry. But like I said right at the beginning, you really don't need crazy complex geometry. You really don't need a ton defined when you're doing 2-axis wire EDM cutting. Have your 2D wireframe. Make sure you set your stock up correctly based on the part that you're cutting. And then go have fun with setting up those things. Land and taper settings. You can do just tapered cuts. The 2-axis world is your oyster at that point. So we'll get out of this 2-axis and we'll go into our 4-axis. Drop this back down, and you can see this is kind of what I mean with the solid model, right? Say you don't have a whole bunch of layers with all this geometry already, kind of parsed through. If you just have this solid model, this can get, a little bit intimidating maybe for creating some of these features. We have 2 completely different profiles on some of these, say like this shape at the top and this shape at the bottom. Well, just in case you're not aware, you can always pull geometry from solid geometry. And I mean pull wireframe geometry. And so just as an example of that, we'll call this extract, because I'm going to go extract some edges from this. Let's hide everything here too. We'll just get rid of all of our tool path and everything there. And from here, we can turn off our solid, turn it back on. And so I don't know what just happened with our stock there. Let me just refresh this. This has been open all morning. Close that out. There we go. All right. So just go add our layer back. We'll hide all that stuff. There we go. And so if you're ever trying to pull geometry from an existing solid, obviously you can pick solid geometry for this. If we go and start, say we'll do an outside or an open, you can pick this geometry. In some cases, it's not, the easiest. Sometimes you might have, close by geometry, that kind of thing. And really, I like using something that a lot of people don't seem to use very often is selections. And so I'll kind of show you here. We'll call it extract to, and I can kind of show you how selecting these things could be made maybe a snap quicker than it is currently. So we'll go to our extract layer, and we'll just make that our top extraction from this profile here. So we'll go grab some of this top profile geometry. Just work our way around. I could use auto connection, but because there's so much stuff and it's on the same Z level, it might be overpicked. So we'll just go manually pick this stuff. Grab you and you. We'll just work our way through like that. Now there is the option, this confuses some people sometimes when I'm speaking with them, is project to Z plane basically means that this geometry, say, is if you had something that is like a helical move, take a thread and it goes down in Z. Well, if you project to Z plane, not only is it going to project to that position, say if I put 1 inch in here or 10 inches, you would see this geometry pop up somewhere above this, and it creates wireframe geometry made up of usually lines and arcs is what you're going to be pulling from most solids. Some will have spline geometry if you're working with some complex solids. Project to Z plane will also flatten your geometry out, which can be a super nifty feature if that's your intention. If you don't want it really messed with, leave project to Z plane off. We'll hit OK. And as you see here, that just grabs that profile from the part and leaves it in that position. We didn't project to Z plane, so it isn't moving it anywhere, and this was already flat geometry. So now we have that extract right there. We can go do this with the bottom. Turned off my extract on top. It shouldn't really get in our way, but for good layer management, I usually like to turn stuff on and off. And so we'll pretty much just extract this bottom surface here. The bottom profile of that surface. It looks like we might be missing a little tiny segment. Nope. Just the graphic showing us little stuff here and there. We'll just continue around. Just end up there. Same thing. Hit OK. Cancel. Now we can see that we have both of our profiles here, just like that. And so, say I wanted to do something with that. We don't have a surface that exists right here, quite like this one. Another thing, too, is you could just pull that geometry directly from the surface. Here, let's go throw extract 3, maybe save ourselves some time next time. If we go and grab that surface, and then we hit OK, and we're not projecting to Z plane or anything like that, we'll hit OK there. We'll cancel. And you'll see that pulled that whole entire surface geometry. And really the main thing that I like telling people to do is if you're not using them and you're using things like this often where you've profiles made up of a whole bunch of different chains of geometry or multi-entity chains where you have to go, if you were individually picking that, you just saw how long it took me to pick that stuff a moment ago. We could pick this and never have to really go pick everything individually once again if we use selection. So this is selected here. If I hit this save button on my selections menu here, now I don't have to go re-pick that. Use our picking tool, selections, and you see that just picked that whole entire chain of geometry with one click. And this is something, like I said, not a lot of people I see are using this, but it comes in handy quite a bit with something like this with wire where you are picking those chains. Even with our premium tool paths where you're picking drive curves and morph between two surfaces or morph between two curves, um, does have you pick chains as the geometry for setting up those tool paths. This can be a lifesaver if you're working with a profile or a chain that has a ton of entities in it. So with this one, we can go here. We'll just do this. Start a brand new file. We'll go do some 4-axis stuff, but we'll copy that geometry over because we could get to all of these tool paths and kind of individually look at each of them. But we'll just do a quick 4-axis setup here. So if we paste, oh, I must not hit copy on that. Sorry about that. We got that. We will copy. We will paste. There we go. Now we have our upper and lower geometry here. So we'll just do a new job. We'll do the same thing. We'll use that Mark 21. We'll go to our stock wizard. We don't have a workpiece here. Once again, I'll show you kind of the benefits of using a workpiece inside of simulation as the main place you're going to see that. But we'll continue on here. Set that up there. Cool. That should be good. I mean, if we want to. No, that should work just fine, actually. So we'll continue here. We'll set our origin at the bottom for our lower guide. Then we'll go do just a 4-axis open. And so here's really where you could get speedy with things like this is, well, those were saved on the other file there, the selections that I had made. So right now we could quickly do that. But that's where, if we have those selections here, I'll just cancel out of this. We'll go do the selection. So top, save, bottom, save. Right. So when we go and select our geometry, this might not be the craziest, most geometry that you could run into. But now we have that selected. And for our lower geometry selection, now we have that selected without having to draw a box or make, changes to what layers are showing up or anything like that. So we'll just make sure our chains are kind of going the same way. We hit OK. And it looks like there might be some flipping here. Let's see. Let's remove our glue stop. It looks like maybe those chain directions were a little bit backwards. Let's go here. There. And there. Maybe I'm missing a piece of geometry. We'll go next. No glue stop. There we go. Let's try a rough and a skim. Now this is a pretty complex surface we were just messing with there, but you can see that kind of reoriented those sync lines once we got into it a little bit. Don't let the initial look intimidate you too much. And you do have some options for syncing, by entity, by proportion, by closest. And, by entity, right now we have the same amount of entities, but that should be just fine with different, sometimes by proportion will come in handy more than by entity. And if you just hover over things, if you have the tooltips on, this could give a far better description than I in most cases, where it tells you kind of the dictionary definition of what each one of these things means. You also can open the help system right from there. And so if you see these tooltips, check out what they're talking about, and kind of take it from there. Like I said, we're just going to do the rough and skim cut. We have our wire, 10th thou wire. Continue on. Not changing anything for posting. Our parameters, we're going to comp. No stop points. We'll leave our lead in and lead out. For this one, honestly, a parallel probably would work just fine. Based on maybe some of that geometry that it's getting in there. It's like point. Where is this going to? Right in smack dab in the middle. So we probably don't want to start there. Maybe just perpendicular. We could just start one side, go to the other, and we'll continue through. Cutting conditions, if it's linked, it'll say right there. Continue on to our parameters. Our skim passes, we'll do reverse skims again just to keep things exciting. System comp off, machine comp on. Get back into our leads. We'll just leave it on perpendicular. And once again, the cutting conditions selected right here. Keep in mind too, if we have any newer users in here, you don't need to get all the way to the bottom of your CAM wizard when you're getting through this stuff. If you get here and you decide, yep, that looks good, compute it. And that's all you got to do. It'll keep everything else the same. Say maybe I did that a little too early. I want to go change my leads. You can always come back to it, but you can hit compute and finish anytime you want to. Now, like we were talking about earlier with the 2-axis, we don't have any option to choose sync lines here because it's basically applying the taper. It's doing a calculation in the background to get that taper. With the land, it's just going vertical, straight down for the land to that distance, and doing some math in the background to apply that taper at the correct position. In here, we have let's turn our solid back on. And really, we don't need to turn the solid back on quite yet. You can see all these parts, and for most of these, even with this one that we just copied, you see that we have the top and bottom geometry selected. Let me see which one is that. That should be later open. There we go. So here we have our top geometry. Let's turn our solid back on. We have our top geometry, our bottom geometry, and then this one does have sync lines associated with it. Here, let's turn all of our other toolpath off. You can see there's our sync line selection. And so that's manually going in and creating sync lines, just like we see here on this layer, for all of these different spots where we want the wire to sync up on the top and bottom guides. BobCAD now inside of version 38 will kind of recognize what you're trying to do between the top and bottom and give it its best estimation of those sync lines so that things kind of stay synced up. And so in some cases, you might still want to go add a couple if you're getting any bad spots of your toolpath, or if you look at simulation and it's marring the surface or doing anything in a way that you don't quite want it to. Adding sync lines is just telling the software, hey, this is exactly where I want you to go do this, rather than saying, hey, you figure out where this is going to go happen. Is essentially the difference there. And so let's give this a quick simulation. We can run that. We're going pretty slow. We can take a gander at how this is looking inside the part. You can kind of see how it's making those decisions using those sync lines, because you'll see it kind of tilt one way, tilt the next way, and try and make the shape that we're trying to make. Now, this one doesn't have a surface because we just copied that top and bottom geometry. But I'd say, honestly, that's fairly close to what that surface already looks like. And here, let's speed it up. We'll wrap it up here with our skim. We'll turn on our, whoopsie daisy. We'll turn on our stock all the way. We'll show that. And then we'll do the same thing down here. We'll remove the chips. This time we can select the chips. And in this case, we're not clicking on the part we want to keep. We're clicking on the part we want to remove. We'll use that center mouse wheel. And there we go. So not quite exactly the same surface that we copied from. I would definitely say some sync lines on that geometry would probably make that a little bit cleaner. But ultimately, that's a pretty close representation of what that other surface is doing. And that's without creating any sync lines. And you can see on this other part, let's exit simulation here. You can see on this other part just how many sync lines are involved when you're doing complex geometry. Like we have our I guess an extruded, gear kind of shape, whatever this is supposed to be on our example part here. Press some Play-Doh through that, you'll end up with that. But you can see how many sync lines are involved when you have a part like this. Obviously this part is a hodgepodge of many different things happening. But for the sync lines, if BobCAD's going to kind of understand that these chains correspond together from top and bottom nowadays, you really alleviate a lot of that work of going and manually creating that geometry or manually pulling that geometry using extract edges and then having to, kind of show everything just like we have in here to X open. And this is all based on the features that we have set up over here, obviously, just to keep it a little bit more organized. But it's just one of those things that if you have those automatically selected, automatically syncing up through the system, it does save a pretty significant amount of time. And really, we could go look at some of these other pieces of geometry in here. We could turn off our sync lines again. So we just looked at this one here. If we just want to post that out, we could go look at how that surface compares. And you can kind of see it is a fairly complex surface for this thing to be thinking about. There we go. We'll get rid of that. It's got, a lot of changing features as it's going around that. Little jut out there where you don't jut out up top, and that's kind of what we're seeing in the simulation without the sync line. So I'd say overall that got pretty darn close. If we want to take a look at it here with the sync lines, this is where they still come in handy, even though it's auto syncing. That doesn't necessarily mean it's always going to do things perfectly every time. So we'll remove that. We can see it's very similar, but in some cases, you'll still probably need sync lines. We can take a look at some of this other geometry that we're working with here. A lot of people always want to look at our extruded gear. It's just a gear with a little twist in it, this shape here. Let's turn this one off. Let's see, this would be a 4-axis inside. There we go. It's always fun finding which one we're working with on here. Same idea, though. And you can see this one isn't using the sync lines. Sync lines are not selected on this toolpath. And you can see how it's generating those sync lines just based on the geometry that we're working with. Now, we can take a look at other things here, too. Like when we set these pieces of geometry up, we go look here. Let's go reselect that. There we go. Let's cancel out of this. Bear with me 1 second. This file is very heavy. No, we don't need to make any changes. We'll just pop that guy back open. Get those guys here. That was this guy. So if you view this chain information here, we have our upper geometry, and this arrow is denoting our start point too. So that's our start point on this upper chain of geometry. You'll notice the lower geometry, you want it to correspond with that so that when you're making these changes to the settings, by proportion, by entity, by closest, you may end up with different results depending on which ones you select. Right now we're picking by closest, and you can kind of tell that it's understanding that based on the top and the bottom and the chain direction, we're starting at the center point of this arc and we're going this way, counterclockwise around the part. We're doing the same exact thing here. And so BobCAD's not only just taking a look at the start point and the direction, but also the geometry features, right? As we go around this, this fillet here on the corner of these and on the interior fillets there, that's exactly where we're seeing our sync lines popping up, right? So it's kind of based on those surfaces that it interacts with. And that perspective just got me a little bit. I was turning it the wrong way. So you can kind of see where it's syncing up just naturally without any sync lines being selected. We could go simulate that one too. Go run that. You can go through here, stock, transparent, and we'll run that. That was probably a little quicker than I could have seen it at least. Play. You can see as it's working through, it's making sure to keep those sync lines lined up. Staying at that consistent angle. Don't worry about the choppiness of the render. This is the pre-render, and it will sharpen up once we get in there. We'll go take a look at that once it's all completed. We'll speed it up a little bit. We can get that one done with. We'll do our skim the opposite way. Turn our stock back on. Oh, and here, sorry about that. Just got rid of my part because I clicked my select chips button. Sorry about that. There we go. So we will get rid of our core there. That must still be connected in some way, I guess. Are we doing our skim pass on there? That should be punching all the way through. There must be some contact surface in there making it not allow me to pick that. You can kind of see in that visibility when we were just looking at the transparent view that it is going through and syncing up. You can kind of see how that render looks. I'll show you this real quick because we are getting to about 10 minutes left. I want to have time for a couple questions if anyone's got any questions in here. If we go look back at it, this is just kind of another tip for simulation because this could be concerning to some people. I've been asked about it plenty in tech support tickets myself. If we go run this, you can kind of see the choppy pre-render. Here, let's go. I've dragged this out a little bit here. Let me just fix this up. There we go. For visibility, we will keep it transparent. We'll go ahead and run this a little slower, maybe slower than that. Really what I'm trying to show here is that kind of lousy pre-render that it goes. You can see it looks a little choppy there. It doesn't really look like a clean cut through there, and that's concerning a lot of the time because people are like, wow, my finish is going to look like kind of garbage if it ends up doing that. If we continue through here, though, we'll speed it up a little bit. And we'll turn our visibility back on. We'll show that, and we'll only keep one part. So a lot of times people get concerned because they'll see things like this where some features are a little bit more bold. But if you go into verification and say we get right into the corners here, using my 3D mouse, get it in there a little bit. You can apply refinements, and that will refine the exact view that you're in. If we reset that, we can zoom out a little bit. But a lot of times the pre-render that you get is not going to be as clean as, if you go refine that toolpath. A lot of times this helps if you have say you're doing a milling job and you have a part with a lot of scalloping because you're doing large step over and you're not accounting for the scalloping of your part. This will show you kind of exactly what those scallops are going to look like and what you should expect to see when you pull it off the machine and that kind of stuff. And so that's kind of the meat and potatoes of what I had to talk about today. Like I said, I know we have a few people in the session. If anyone's got any questions, I'd be happy to answer those. Not getting anything here right now. We'll just give everyone a minute. If there are any questions that are eating away at you with regard to wire EDM, and that was just a couple of these shapes. You can see you got this one all arcs, this one all lines. You can do some pretty neat stuff with wire EDM. The zero tolerance machining nickname is very applicable when it comes to wire EDM. Don't have any questions quite yet. We'll give it another minute. But if you do have any questions after this, obviously feel free to let us know. If there's something we can help you out with, obviously we offer several different training options. We have in-house and on-site, where you can come down here to Florida. We can come out to you, visit you wherever you're at, and train you right at your shop, right from the comfort of your own chair. We have online training where we can connect with you, kind of similar to this, but you'll be able to talk to me too in online training. The whole sessions get recorded. We get it over to you, and now you have your own personalized training video, which is nice, especially if you forget that one step right in the middle of the program that you can't remember. Online training is great because the whole thing gets recorded. We can send it to you, and then if next time you miss that step, if you're anything like me, it's always that thing in the middle that I can't remember, that one step that slows me down. Well, now you have a video that'll show you how to do that. We also have Launchpad training, and we do these webinars twice a month, or every other week. And so if there's topics that you'd like to see, please share them with us. We're always looking for new things to talk about in here. And I don't have any questions quite yet. So for now, we'll say goodbye. And thanks for taking a look at our webinar today. And we'll see you next time. Thank you.